Unit 3.3, Characteristics of Graphs, Part 1. First, let's do the warm-up. It says determine whether each function is linear or nonlinear. Is it a line or not? Very simply, we can find first the intervals. How far is it from here to here? A half, right? Okay, 0.5. And here to here? Good, 0.5. And from here to here. Okay, good, good, good. So this is the same continuous. And what about over here? I'll give you a little minute. And if you're struggling, remember this is $2.50 and this is $3.75. Good, good. So a buck and a quarter. Difference here. Mm-hmm. A buck and a quarter. And our difference here. Mm-hmm. A buck and a quarter. So in this case, since all of them are the same, then we know this is a line. The same, the same. Another way is to take your y value, because helps you to find your slope, remember? Take your y value, put that as your numerator, and divide it by your denominator, 1.25. And that gives us our slope. And what is the slope? And of course, when we simplify it, then we find 2/5. Question, of course, how in the world do we get 2/5? Well, we can pretend this is money. Every time you see a decimal, pretend it's money. Most people really do like money. And so here, if this is money, and I have two numbers behind my decimal on the bottom, then let's make two numbers behind the decimal on the top. So we just add a 0. So that means I have 50 cents and I have a $1.25 or $1.25. What number goes into 50 and to $1.25? And we know we can get quarters out of that. So we got 25 cents goes into both. So 50 cents divided by 25 means it's 2 quarters. And a $1.25 divided by 25 cents is 5 quarters. So therefore our slope is 250. I'm sorry, our slope is 2/5. And again, since these are the same and these are the same, and there's no break in the numbers, then we know we have a line, and that line has a slope of 2/5. But all you have to do, of course, is just tell whether or not it is a line or if it is not a line. So I need you to do 2 and 3. All right, here, so let's talk about video. I'm sorry, let's talk about vocabulary. I probably need to take a little breath. All right, so here with vocabulary, it says we have our x-intercept, y-intercept, positive intervals, negative intervals. Yes, of course, you've seen x-intercept and y-intercept. And we know that your x-intercept is the x-coordinate of a point where the graph crosses the x-axis. Key, very, very important. Let's keep it pink. That x-intercept, it is also known as 0, root, solution, and what did we learn in the first lesson? It is also called independent. All of those refer to your x-axis. Independent, zero, root, solution. Now your y-intercept is simply where it crosses your y-axis. It has no other names. Okay, I'm sure there is an I stuck in there somewhere. All right. All right, it has no other names, just y-axis. Positive interval. This is the interval between your x-intercepts where the graph lies above the x-axis. Negative interval. This is the interval between the x-intercepts where the graph lies below the x-axis. So let's use positive. Let's go green for positive. Positive, not green. Positive interval, key. The key is the graph lies above. Hey, let's wait. The graph or part of the graph, the parts of a graph above. Golly, the x-axis. So again, it's the part of the graph that is above the x-axis. Your negative interval, let's go soft blue. Your negative interval, very simple. It is the graph, part of the graph below the x-axis. And I know it sounds confusing, but watch, it's so easy. All right, let's go check. All right, let's look at the graph. It says use the graph to estimate the x-intercept and y-intercept of the function and describe where your function is positive and negative. Let's look at the simplicity of it. The x-intercept, where does it cross your x-axis? This is your x. You can write that. You don't need me to write that, but I'll do this first one. All right, we know our x-intercept is crosses here at 2, so our x-intercept is going to be 2, and we're going to use a list 0. And I know it's not a list, but I want you to remember we're going to use parentheses and not just write 2. Then we have the y-intercept. Where does it cross the y? Looks like it crosses at 4. So that's going to give us the point of 0, 4. And if you take note, each of these intercepts have a 0 as part of their answer. The y has the 0 first, and the x has the 0 last. Every time. Now let's talk about this positive interval. Positive interval, it says the graph above the x-axis. This is my x-axis. Let me use this red right here. Let's see if I can draw a straight line. All righty, so right, whoa, that's a little bit too thick. How do they say it? Laying it on just a little too thick. All righty, so what's right here? This is our x-axis. All right. Okay, kind of off a little bit. Try right there. Okay, off just a a smidge, but x-axis nevertheless. And the positive says the part of the graph that's above the x-axis. What's above the x-axis? All of this right here. Positive, it looks like it's supposed to be green. So let's go ahead and find us green. And let's stick in that old joker. And make 2. So everything up here is positive. And the negative says it's blue. So everything down here is negative. Question is, how do you write that? Hey, it's very simple. Remember in the one lesson we talked about that arrow, and wherever that arrow is going, it is going to infinity. The arrow means infinity, and at the top, we have, just go green. At the top is our y. Let's just keep it red. Top is the y, and it is positive infinity. The bottom is negative infinity. And on our x, this is negative infinity on our left, and this is positive infinity on our right. And this arrow, because we have to talk about positive intervals, and the key is X, 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 X. So first, well, no. At first, I was getting ready to apologize for giving you the Y infinity, but I'm not, because you need to remember that also. For that might come up when they ask you about domain. I'm sorry, when they ask you about range or domain and range. All right, but here is we're only concerned with X. Only concerned with X. Only concerned with what? X. That's all. Just X. So we know that this is continuing to go. It's going and going and going, as little kids say, and go on and going and going. And look down. Where is it going? It's going to negative infinity. So our positive interval starts at here, but we put the lowest number first. So our negative positive interval is going to be negative infinity, and it stops at 2. Again, we're looking at 2, and it's going towards the left, so it's going towards negative infinity. Our negative interval, look at where it's going, and continues. I know my line's crooked, and we can see it's going towards positive infinity. Remember, we're only concerned with x. We are not concerned with y, only concerned with x. All right, so that means our negative infinity, it starts at 2. And where is it going? It's going to positive infinity. Just because it's called a negative interval doesn't mean it's going to be a negative infinity. It's simply asking you what part is in that negative infinity zone. Or let's say we were talking about being in the water, okay? And here, down in the water, who needs to be saved? All right, so who needs to be saved in the water is the 2, possibly, and everything below it. All right, as far as, because all of that's in the water. So when that everything going towards positive infinity needs to be saved. All righty. So how about you try your hands here, pause your video, and do this one. All right, so of course, I'm not going to put your x-intercepts or y-intercepts, but hopefully you highlighted your positive and you highlighted your negative. Now, your positive in this case is going to give us two separate answers because it's broken. One is on this side and one is on the other side. Not really a broken line, but separate. All right, so we know this goes to negative infinity, and we put the lowest first. So negative infinity to -4. And the positive is also 3 to positive infinity. So our negative interval is here, everything below is from -4 all the way to 3. Awesome. All right, so this gives you a little taste of do example 2. You should be able to do that by yourself. Lunch, it says find intercepts from a table. Find the x-intercept and the y-intercept. And the one thing we talked about earlier was that when we find our intercepts, let's see. Trying to remember which lesson, because we know everything just builds up on the other thing. Looks like I'm gonna have to go here, click here, go here. There it is right there in my face. So we remembered, as for this is concerned, as it says, finding your intercepts from a table, we know that the x-intercept has a 0 as your y value, and the y-intercept has a 0 as your x value. So you can do this. Awesome. So here, which is x, which is y, which is independent, which is dependent, and you got this. All right, B says describe what those intercepts mean in the context of the situation. So here you have to read the situation, look at the table and what they're giving you, and what does it mean? Yes, this is your time to think. I know, I love you too. All right, example 4, estimating solutions by equations. So here it says Haley is ordering invitations for her graduation party. She has $40 to spend. Each invitation costs 96 cents. The function m equals 40 minus 96 cents per invitation. It represents the amount of money Haley has left after ordering P party invitations. Find the 0 of the function. Describe what this value means in the context. Which one represents 0? It says find the 0. Remember? So is 0x or 0y? Yeah, go back to your notes. Today, yesterday, day before yesterday. Go back, go back. You didn't even have to go far, did you? So that means you need to find your x-intercept. And tell what it means. And of course, your question is, but how do I do that? That's a good question. Good question. And let's think a little bit first. All right, so let's look at your setup. So once again, we're looking for x. So here we're going to, very simply, let's just rewrite it real quick. We got m, and we know m represents our y value. 4t minus 0.96. Yeah, I'm not going to put the 0 because it's just 96 cents. P. P represents the number of party invitations, the number of. If we put this on a graph as far as independent and dependent is concerned, then we know that here is talking about money, and P is representing y equal, you remember y equals mx plus b, right? They just flipped it. So P represents our X, and our X is our number of invitations. So this would be our invitations down here, and this would be the money that is being spent. And it's Y, as it's telling us right here. M is the money. All right, I'm not going to finish putting that out. I'm just showing you what that graph might look like. Now, it asks us for the 0. So in order to find our 0, all you're going to do, which is in order to find x, all you're going to do is change your y to 0. So your setup is 0 equals 40 minus 0.96 cent per invitation, and you can do the rest. And once you find your answer, what does it mean? Describe what it means. Okay. I know, easy peasy, right? Okay, and then you have your exit ticket. And very simply, for each function, identify your x-intercepts. Didn't even ask for the y. You got this.